All right, tonight I want to talk about a few other ways to describe data. Previously we talked about measures of central tendency, and this time we're going to talk about measures of dispersion. And first I'm going to show you why we talk about these. Look at these three different sets of data here. That's 1, 2, 3 different sets. Your quiz grades in this case were 180, 60, 40, 20. Here this student got all 60s. This student got 3 100s and 2 zeros. As you can see, these three sets of data look very different. When we calculate the mean for these data, we find out that this one is 60, this one is 60, and this one is 60 as well. So you can see, if we just look at measures of central tendency, these all look the same, when in fact they're all very different. So we need a second descriptor to get a real idea of what the data looks like, and that's our measure of dispersion. And in this example we're going to find the standard deviation, and that'll show us how the data is dispersed about the mean. The formula, I've got it broken down here. The first thing we do is subtract each data item. I'm going to do it just for this first one, and then I'll just give you the answers for the second two. We find the distance each one of these items is from the mean. So the mean is 60, 100 minus 60 is 40. 80 minus 60 is 20. 60 minus 60 is 0. 40 minus 60, that's negative 20. And 20 minus 60, that's negative 40. So there's our distances from the mean. And if you've done this correctly and you add this column up, it'll always equal 0. So we've done this correctly, but we're not going to add it up. We're going to square each one of these terms. And what that does is it makes our results all positive, because we can't add, when we're talking about distance, negative really doesn't have any meaning. So we want it to be positive, so the formula takes care of that by squaring it. 40 squared is 1600. 20 squared is 400. 0 squared is 0, of course. Negative 20 squared is positive 400. And negative 40 squared is positive 1600. Alright, the next step in this formula is this is the uppercase sigma Greek letter. That means to sum. We sum up each one of these differences squared. So we sum up this column, and that becomes the numerator, and then we'll talk about what the denominator is. So 1600 and 400, that's 2000, and 0 and 2000, that's 4000 total. So we'll put that over here, 4000. And the n, the n is the number of data items we have. There are 5 of them. So that's our formula. We're going to want to know the square root of, let me see if I can write this upside down, of 800. Now square roots are not a pretty thing to calculate by hand, so I did cheat and use a little calculator on the computer, and I got, for this first set of data, 28.28. So the standard deviation is 28.28. That says that on average the data items are 28.28 from the mean. So that kind of describes it. Now the second set of data, notice they're all 60s. When you find the differences, you're going to get all zeros. So the standard deviation for this one is going to be, let me just write these on here, it's going to be 0. So that's very different. And the standard deviation for the last one, these are the furthest away from the mean every time. And let me see what that comes up with. The standard deviation for this last one is 48.99. 48.99. So you can see I got these written all over the place now. I got one here, one over here, and one up here. you can see that even though the means are all the same, the standard deviations are very different. And that describes data sets that look very different as well.